After having used the method of substitution to find indefinite integral, now we're going to apply that to definite integral. So, say for example we want to calculate this definite integral I, which is between 1 and 2 of 2x root of x squared minus 1 dx, and we need to use the substitution u equal x squared minus 1. So, okay, I'll do it. So, do it first method, and then I'll show you how to go through a shortcut. So, du over dx is equal to 2x. So that means that 2x dx is equal to du. So that means that, okay, so that's I is equal to, okay, so important. When x equal 1, we just need to change the boundary of integration. So I'm just going to rewrite the thing. So it would be root of u du, but the problem is the boundary of integration have changed here, because we are not dealing with x, we are dealing with u and So when x equal 1, what is the value of u? Well, u equal 1 square minus 1, which is 0. So therefore, we can replace that by 0. And when x equal 2, what is u? Well, u is 2 square minus 1, which is 4 minus 1, 3. So therefore, again, we can change the boundary of integration here to 3. So super duper important, the boundaries of integration must be recalculated. Right, from there, not too difficult, it's basically u power of 3 over 2 over 3 over 2 between 0 and 3. So I is equal to, well, that's 2/3 of u power of 3 over 2 between 0 and 3. So it's 2/3 of 3 power of 3 over 2. Yes, minus 0 power of 3 over 2. Yes, so that's 2 power of 3 over 2 over 3. Okay, we can simplify that a little bit. It's 2 times 3 power of 1/2. So it's 2 root 3. Okay, let's do another example. We want to find minus 5, from minus 5 to 3 of x root of 4 minus x dx, and we use the substitution u equal 4 minus x. So that means that du over dx is equal to minus 1. And let's calculate the boundaries of integration immediately. When x equal minus 5, well, u is 4 minus 5, which is 9. And when x is equal to 3, u is equal to 4 minus 3, which is 1. So therefore, the integral is equal to the same than, careful not to move the boundary of integration yet. So so du here, du equal to minus dx, so dx is equal to minus du. So and there we have x is equal to 4 minus u, so it's 4 minus u root u times minus du. Right. So here, because I've got a minus sign here, what I'm going to do is that to get rid of it, I'm going to alt and kind of change the boundary of integration, that's the same than from 1 to 9 of 4 minus u root u du, which is from 1 to 9 of 4u power of 1/2 minus u power of 3/2 du. Okay, so that's I equal, now we can integrate. It's 4u power of 3/2 over 3/2 minus u power of 5/2 over 5/2 between 1 and 9. Can we simplify that a little bit? Yes, so it's 8/3 u power of 3/2 minus 2/5 u power of 5/2 between 1 and 9. Okay, so now, so it's u power, u times 9 power 3/2 over 3 minus 2/5 9 power 5/2 minus 8/3 times 1 power 3/2 minus 2/5 times 1 power 5/2. Okay, we can simplify that further. I'm not going to do it. You get the idea. It's just a bit of manipulation of algebra, but I've demonstrated the most important thing, which is how to calculate definite integral using substitution. So, very important step. You once you have defined the substitution, you need to calculate du over dx to replace dx by the corresponding du, and super duper important, you need to change the boundary of integration. Now, you will note, and that's what I was trying to explain before, that you don't need to go back to the indefinite integral with x, as we've done in the previous lesson. We just, once you have changed the boundary of integration with the new value, it's fine.